Alright, here is our third video for the week, and this is about multiplying and dividing fractions. Okay, so hopefully you remember when you multiply fractions, you're going to multiply straight across. Okay? And then you just multiply away. So 3 times 1 is 3, and 8 times 2 is 16. Okay, again, check, is that reduced? And the answer is yes. No number divides into both 3 and 16 besides 1. Okay, 2/3 times 5/8. I'm going to do this one two different ways here, which I'll show you in a minute. Again, we're going to multiply straight across. And then we go 2 times 5 is 10, and 3 times 8 is 24. Okay, now you're probably going to notice that this is not reduced all the way. These are both even, so that means I can reduce it some more by dividing. So what I'm going to do is divide each of those by 2 since they're both even. And then I will get the answer 5 over, oops, sorry about that. Pardon that squiggly there. I will get the answer 5 over 12. And that is reduced again because no number besides 1 divides into 5 and 12. Okay? So this is the other way to do it, and this is called cross-canceling, which some of you may remember. And you want to cancel from denominators to numerators, never straight across. That doesn't work. So you cross-cancel this way. It's kind of like an X, which is why they call it cross-canceling. And that gets a little confusing with something called cross-multiplying, which we will learn later on. But remember, we always multiply straight across. So you want to check, can you divide 2 into 8? And look, the answer is yes. So 2 divides into 2 once, and it divides into 8 4 times. So what we're kind of doing is reducing the problem before we even do it. So now if I rewrite this, I have 1/3 times 5/4. I know this is an improper fraction where the numerator here is bigger than the denominator, but we're just going to run with that. That's perfectly fine. So now 1 times 5 is 5, and 3 times 4 is 12. So to me, cross-canceling is the way I do it. It's quicker. I don't like reducing at the end. Either way works just fine. If you're comfortable canceling, I know it makes the problems a little messy, but if you're comfortable doing that, then cool, go for it. If not, then just multiply and then reduce it at the end. Okay, so here's another one, 9/10 times 5/27. And I'm going to do this one the canceling way. Again, I'm going to draw my arrow here. We're multiplying straight across. You could just do that, but then you'd have 270 on the bottom. 10 times 27, that's a big number. So let's try to cancel it a little bit and reduce. Okay, so 9 and 27. Can you reduce that? And the answer is yes, absolutely. 9 goes into 9 once, it goes into 27 3 times. So already right there, we're a lot simpler. But you may also notice, look at this, 5 and 10. Can we reduce that? So yeah, 5 goes into 5 once, and oops, sorry, pardon my slanted one there, and it goes into 10 twice. Okay, so now the tricky part sometimes is reading what's left. So this first fraction is now going to be 1/2 after we've canceled the 9 and the 27. And this fraction is going to be 1/3 after we've canceled the 5 into the 10. Okay, so 1 times 1 is 1, 2 times 3 is 6, so we get a sixth. So to me, it's way easier to cancel in the beginning like that if you can. Okay, most of the problems you're going to do aren't going to have numbers this big, but on occasion, if you run into them, try to cancel it out. Try to do that cross-canceling in the beginning to make it simpler. Okay, so to divide fractions, we're going to change the problem to multiplication by the reciprocal. So let remind you, what's the reciprocal of a fraction? Well, it's just the fraction flipped over. So what's the reciprocal of 3/4? Well, we just flip it over. The denominator becomes the numerator, the bottom becomes the top, and the numerator becomes the denominator, or the top becomes the bottom. We just flip it over, 4/3. Okay, so let's look at a few here. I'm going to turn the page. Okay, so what is, we'll just do a couple of them. What is 5/6 divided by 2/3? Okay, do not do any canceling in the beginning. If you want to do cross-canceling, we'll do that after we've changed it to a multiplication problem. Okay, so now we need to change it. Anytime you see division, we're going to change it. The first fraction always stays the same. Division becomes multiplication. The second fraction flips over. Okay, So it becomes multiply by the reciprocal. We got to flip the second fraction over. And again, the first fraction there doesn't change one bit. It stays the same. And then we multiply just like we did before. We're going to multiply straight across. Some of you might see that you can do some cross canceling here, but I'm going to hold off just to keep it so it doesn't get messy. But I will reduce it at the end. So 5 times 3 is 15. 6 times 2 is 12. Okay, so many of you will notice that 3 divides into both of those, and that's great. So if 3 goes into 15 5 times, it goes into 12 4 times. And you'll see here we ended up with an improper fraction. That is completely fine. You do not need to change that into a mixed number. In fact, I would prefer it if you didn't. I certainly won't mark it wrong if you do, but what I care about it mostly is that it's reduced, and I like improper fractions better. So we're just going to leave it as 5/4. Okay, let's look at one more. So I got 9/10 divided by 3/4. Okay, so again, division becomes multiplication by the reciprocal. First fraction we leave alone. Division becomes multiply. Second fraction flips over. So this becomes 4/3. Now this one I am actually going to do some cross canceling, and I'll show you how that works. Remember, we don't cross cancel at all until we make it a multiplication problem, or it just, you could if you're careful, but I highly recommend to not, because you have to think about changing the problem around to a reciprocal. So let's just not even mess with that. Make it a multiplication problem first and then cross cancel. So here, look, 3 goes into 3 once, goes into 9 3 times. Now what goes into 4 and 10? Well, that's 2. So 2 goes into 4 twice, and it goes into 10 5 times. So let me rewrite this here so it's a little neater. Again, I like doing the cross canceling a lot. I prefer this than reducing it at the end, but if you want to reduce it at the end, that is completely fine. So this is 3/5 times 2 over 1, which is just 2, but I'm going to put the 1 down there. I'm going to leave that there. So again, you can see how multiplication works because we're going to time straight across, and 3 times 2 is 6, 5 times 1 is 5. Okay, so we have done our multiplication. We have 6/5. Again, I prefer this as an improper fraction than as a mixed number, which would be 1 and 1/5. And if you want to change it to that because you like it better, that's fine. But I'm going to leave it just like this. Again, what I care about is that it's reduced. And since we did our canceling, we reduced it in the beginning, and we're done. So 6/5. Okay, so I hope multiplying and dividing is okay. And as I say, please, please, please do not hesitate if you have any questions or if you're confused at all to send me an email so we can take care of that as soon as possible. All right, thank you.